Excellent. Well, hello everybody. My name is Richard Hughes. I work for Red Hat on emerging technologies and desktop stuff and firmware stuff. And I was asked by Sri and Alison to give a talk about how to basically build an ecosystem. And the logic is that I've worked on this stuff for like 5 years now. We've managed to get companies to care about Linux users where perhaps they haven't in the past. And there's an awful lot of overlap between a firmware ecosystem and an app ecosystem. Right, let's do next slide. So, the basic problem we were trying to solve 5 years ago is that users just weren't updating firmware. Firmware is not this thing anymore that is just a kind of like add support for new CPUs and that kind of stuff. It's actually security critical. It's like an OS underneath your OS. And so not updating firmware is a security nightmare. So the problems were fourfold. People didn't know how hardware they had installed, whether it was an NVMe drive, an ATA drive, etc. They didn't know updates were available. So they didn't go to support.dell.com on a monthly basis and search for their serial numbers and stuff. And even if they could get hold of them, a lot of the vendors were supplying the files just from random, well, literally FTP sites with, if you were lucky, an MD5 checksum without any kind of certificates or any sort of assurance that the firmware hadn't been tampered with in some way. And then even if you did manage to find the firmware, it might be that you were not allowed to apply it. So a good example here is I have a LG monitor I use, and the only way you can update the firmware is using Windows XP or Windows 7. It doesn't work on Windows 10. Or I have a Lenovo server which has xClarity on it, and that only works in RHEL 7, doesn't work in RHEL 8 or RHEL 9. So even if you manage to find the update, and it might be that the vendor that you bought the laptop from, if you had bought the unifying receiver at the same time from the Dell laptop, it might be that you had to go to 2 different vendors to find the firmware, and then it wouldn't apply anyway. And so the consequence of this is people just weren't doing firmware updates, which is something that my boss said this needs fixing. So what did we do? I built 2 projects. The LVFS is essentially the web app, and it's basically the metadata source of both the firmware and the list of firmware. And the idea is the only people that you have to use the LVFS are the ODMs, the OEMs, that kind of thing. People like, I don't know, Dell, Lenovo, etc. And everyone else just downloads a shared metadata catalog of all the different firmware that's available. And then the other side of the project is once you have all that high quality metadata, you need to be able to apply it onto your hardware. So I guess in the same way you can sort of relate this back down to like FlatHub and the local like lib flatpak scenario, where you need a mechanism to actually install the data onto your computer. And so fwupd is a project that I think it's got about 34 different protocols now, and there's another sort of 5 in development, where you can just take a blob of firmware and blit it to an NVMe or ATA or Wacom or VIA, or there's just dozens of different vendors that have all these different bespoke protocols. And then I guess unlike maybe like how Snap and Flatpak work, we kind of close the circle back. So we have this idea of you report status optionally, and it's completely opt-in, where if the update went well, you might report the status back to the LVFS just with a sort of Boolean success. But if it failed for some reason, you get lots of system debugging, so that if there was a substantial number of failures coming back for a certain firmware, you can kind of work out that the firmware is failing because, I don't know, the kernel version is too old. And so the fix there would be to go back into the firmware on the LVFS and add an extra requirement to say the firmware must be at least this new, otherwise don't suggest it. And it's a really good way of kind of working out issues. So when we first started, we had all these issues where, I don't know, Debian had a really old libUSB version, which would trigger a bug which wasn't triggered in like all the things we were testing on, like Ubuntu, Fedora, etc. It's really useful. Like I say, it's completely opt-in, but it meant we could close the site. It also means I could sleep well at night, because if a bad firmware goes out, it means that it's automatically demoted from the public back to being private again if it fails more than a certain number of times. So if it fails below, say if it increases like 1% error rate or something, it automatically gets demoted back down. So it's kind of a bit more exciting than maybe an FTP site would be. So actually looking at the architecture, this is, I guess, fairly similar. Actually, what fwupd does is probably not super interesting for this audience, but it's essentially like what Snap and Flatpak or PackageKit are doing. Essentially, you have 3 layers. You have the internet layer with the LVFS as the kind of the download server, and then you have this dumb CDN. The middle layer is the session, which might be something like Gnome Software, Appa, the KDE Software Center, or even the command line, fwupd. Alright, and actually one of the things that was interesting in this is we're analysing the user agents that were actually requesting firmware. 99% of the downloads were being done using a GUI client rather than 1% being done using command line, which was a real surprise for firmware. So we had to make it beautiful and think about UX all the time. Now, I put in the notes that it optionally downloads metadata from the LVFS. The idea here is you don't have to use the LVFS. Lots of companies don't use, like for instance, if you're a 3-digit US agency, none of your servers have internet access. And so you might be getting the downloads, the metadata and the firmware themselves from an NFS share or a Samba share or something. And so it's not essential that you use the internet sort of side of things. The lowest bit, the system service, is fwupd, and that's basically enumerating. So in the app ecosystem, you'll be saying what apps are already installed, and actually lets you add and remove apps that are sort of specified from something like FlatHub or firmware from the LVFS. Yeah, so I guess the main comment here is people will ask all the time, like, why didn't I write this in Go? Why didn't I write this in Rust? And 5 years ago, those ecosystems were even more immature than they are now. And the other thing is people who are actually writing the code to flash the firmware are probably firmware engineers. And lingua franca in firmware world is C. So it was ridiculous to choose any other language that wasn't C if you're going to be asking people to contribute to your project who are potentially firmware engineers. Of course, C is kind of pretty clunky, and it's not particularly nice to use without the sort of synthetic sugar of something like glib, and using something like gobject, which is the kind of a nice, easy sort of middle ground between not using C++, but still having object-oriented programming sort of techniques, meant that we kind of had the best of both worlds, where we could say to people, this is how you use Gera and gobject stuff, but also get the C programmers to contribute to our project, which I'll come into is kind of important. Yeah, the other side of it was the website. So I'm not a web developer, and the idea of the LVFS right from the start was to be as simple as possible. There was no, I didn't want to spend time building the stack and writing the stack. And I call it architecture astronauting, where it's like you've specified this thing as a microservice architecture that can be run by 1 billion people or whatever. The initial version of the LVFS was just a website. I think it was even written in PHP or something. It was pretty rubbish. And you could just upload files, which would be decompressed. The metadata was all smashed together, and that was basically it. And then from that, it organically grew to whatever we needed, rather than trying to do everything before. It kind of works quite differently to Microsoft Update as well. So I'm kind of keen on the privacy stuff here. So the way Windows Update works is you would do a request, and it enumerates all the hardware on your PC, and it sends all that information about your hardware and what firmware versions are installed up to one of the big servers in Microsoft somewhere, on their banks and banks of servers processing these requests. And then depending on the rule engine that's running on the servers, it'll send you a bespoke reply back that says you need to install this update, grab it from here. That's great if you have banks of servers and you don't mind sort of sending your hardware details to a third party, but not something that I wanted to do. And so the way we did it, we had everyone just downloading the shared metadata catalog. So everyone downloads exactly the same file from a dumb CDN. So I could have, I don't know, like 10 million people a week were downloading this file initially, and it was costing me $20 because everyone's just downloading off this geo-replicated CDN. And it also meant I had no idea of what hardware people were running, because it was just everyone was requesting the same thing. The only way you could sort of find out is what firmware they were requesting, but that's kind of required anyway. The flip side of that is we did a centralized firmware distribution. So everyone downloaded the metadata, but as soon as you wanted the firmware itself, you had to download that from the LVFS. Now, kind of the textbook way, the textbook reason for doing that is if there was a problem with the firmware, or it needed resigning, or there was some sort of modification to it, we wouldn't have to like invalidate CDNs around the world, and we could pull it straight away with no delay. But really, it's statistics. Because if we go to a big OEM and say something like, hey, there's a lot of Linux users who run lots of different computers, and they've downloaded probably quite a few updates, it's a lot less compelling than someone saying, hey, there's 10 million users hitting this website per day, and we've delivered, 28 million downloads since we started for 2,500 different bits of hardware. Once you sort of give them exact numbers, that's a lot more compelling to the likes of Dell, Intel, HP, etc. That sort of takes attention, and there's no real way of sort of putting all these files on some mirror somewhere and then have any idea of how effective and if your system's actually working. Also, randomly about the sign, it's a really good way of like sort of mental health point of view as well, because I get emails maybe, I don't know, once a day, twice a day, saying you've done it wrong, this is bad, you should use this language, you should have done this instead, you should have used React, you should have done this, that and the other. And you look at the sign and you think, well, actually the number keeps going up, so that's kind of like proves that something's going well. So it's kind of like a nice sort of mental health kind of balance on that. And we just turn on the mic. Is that better? Maybe I should just stop getting so excited and stop shouting. Cool, no worries. Right, so the other thing is with the web app, I didn't want to be spending time writing middleware service. Like the whole intention of this was to get firmware updates to end users as quickly as possible. So I chose an existing high-level language. It doesn't have to be hugely performant. It's probably being used by 3 or 4 ODMs simultaneously, which is nothing from a web app point of view. And everything else is being geo-replicated on the CDN. So I chose Python. It's using Flask as a kind of a high-level, kind of like a abstraction layer, and SQL Alchemy as kind of an ORM, which is probably horribly inefficient, but works really well, and is certainly good enough and easy to use from my point of view. So my point is, there's no need to architecture everything for sub 1 millisecond response time when it doesn't matter. And the whole point of the architecture is to get firmware updates to users, or in LES's point of view, we want to get applications to end users. We don't sort of care about the plumbing. So I spent a lot of time, this is what, 2015, emailing an awful lot of companies, probably, I don't know, 300 or 400 different companies, basically saying, hey, I'm Richard, I work at Red Hat, I've developed this system for installing firmware on devices, I've got this website which you can upload firmware to for Linux users, are you interested? And generally the response was either, we don't care about Linux users, or yeah, kind of maybe, it sounds interesting. But the most common one was, we're already customers with Red Hat, we're partners with Red Hat already, can we switch to your Red Hat email and talk about stuff under NDA? Now obviously working for a big company like Red Hat, it is, I guess there's negatives and there's positives as well, but in setting up something like this, it was hugely, hugely beneficial, because I could talk to the Logitechs, the Wacoms, the Intels, the HPs, the Dells, and they knew that Red Hat were doing this thing rather than some random bloke, as I was described by Microsoft as some bloke who works in his shed, which is kind of true, but maybe not in the spirit of things. So yeah, so a lot of people were talking about this stuff as a good thing that came from Red Hat rather than some random person. Although the kind of the subtext here is that a lot of the maybe the first 3 years of the LVFS, it was running on a little HP microserver underneath my stairs on my broadband, which is a point I'll come to in a minute. So let's look at the last timeline. So we started 2015, 16, and the first company was Husky, which is a company that I happen to run, which produced the ColorHug hardware. And that was kind of like the first testing, sort of the real test for it, because we had like an actual legitimate legal company, and we had a device that we'd have a custom flashing protocol with a flashing file format and that kind of stuff. And that was like a really good first test. We could get into Fedora, test it. Does the architecture work? Does the debug interface work? What import export tools do we need, etc. And then the next step was talking to the people that could help me with this stuff, the people that would help me bootstrap this stuff. And it turns out open source hardware is awesome, because the sort of people that are producing open source hardware are producing low volumes of things, and they're highly technical people. So something like, I don't know, USB smart charger for something, they might only produce 200 per year, and they currently host the firmware updates on some, I don't know, some random FTP site with no signing, no MD5, whatever. And if you say, look, I've got this free service, it kind of probably works for a use case. And it's completely free, and we'll do signing, and we'll manage all the UI and the command line stuff for Linux users. They were like, that sounds awesome, it's less for me to do. And also they were the sort of people that if something was missing, that a feature they needed, either as a flashing protocol or in the website, they'd submit a patch, which was sort of awesome. And it was like a really good way to kind of kickstart the entire ecosystem. 2017, Dell were approached me sort of through Red Hat, and said, look, we're thinking of doing this thing which was sort of similar to what the LVFS was, but it makes way more sense for us to collaborate, because we don't want to be in the sort of the business of maintaining a web service. So maybe we could work together. And so Dell added support very quickly for their XPS line, IoT line, that kind of thing, edge stuff. And that was great. The problem is, when you're an early adopter, you've got to do an awful lot of the work. So Dell wrote like the Synaptics MST plugin, the Thunderbolt plugin, and did a lot of the work with the UFI Capsule plugin, which incidentally was written initially by Peter Jones. So he kind of absorbed his project, sort of, I guess, claimed the credit for it. But it meant that Dell did an awful lot of work initially. Logitech got hit by a security issue called Mousejack in 2018, and their hardware was basically being pulled out of data centers and stuff because you couldn't apply firmware updates if you're running RHEL. And so they kind of forced to join the LVFS and push updates out using fwupd. And they added support for their unifying hardware. And it's like they only uploaded maybe, I don't know, a dozen firmwares. But it appears that there is an awful lot of unifying hardware in the world, because all those 12 firmwares have been downloaded millions of times, and it's brilliant for end users who don't have to worry about their machines being taken over at coffee shops and things with unifying Mousejack. Now, I put down 2019 for Logitech, but it's not kind of tells the whole story, because Logitech relies quite a lot on their ODMs, actual people that make the machines. And so Lenovo's way of doing it was to get their ODMs and their IHVs, their independent hardware vendors, people like, I don't know, Wacom, Realtek, VIA, that kind of thing. People actually make the silicon that gets sold to the people like Foxconn, Wistron, the ODMs, and then kind of sell it under contract to the OEM. And so we kind of integrated the entire supply chain. So there were VIA engineers writing plugins for VIA USB hubs, and Realtek engineers writing plugins for Realtek USB to Ethernet drivers and stuff. So that was great. And Lenovo obviously reused the code that was written for Thunderbolt, and reused the Synaptics MST and the UFI Capsule, but still had to write quite a lot of code themselves. And so they were probably working on this before the Logitech announcement. But it now means we have ThinkPad, ThinkCenter, ThinkStation hardware supported, which is great. HP last year literally found out they were losing contracts because they couldn't supply firmware updates in the LVFS, and were kind of forced to add support for some models that they wanted to sell for various government contracts and things, and then found out actually there was a huge PR win for joining the LVFS, and that sales of those models went up spectacularly. So they've added a support this year for an awful lot more hardware, and I've been told an awful lot more is planned. And HP, all they had to do was write the HP specific plugins for things like the HP CMX hubs and things. But they could reuse the VIA plugin written by Lenovo and the unifying hardware written by Logitech and Synaptics MST by Dell. You can sort of see how this is going. Like, I've only listed a few OEMs here, but the most common thing, OEMs join the LVFS now, and they just can't believe that it's free. So someone will join and they'll say, look, I've got this hub, it's got a VIA USB hub and this Realtek chip, and it's got this ANX chip. And I'm like, yeah, well, that's supported. You just have to add these 6 lines to this file with your vendor ID and your product ID, and it just magically works. And they're like, how does this work? It's incomprehensible. They don't have to pay any money. They don't have to do any work. It's the fact that open source means you can all reuse the same code, and we can all support this, all these different products with this one code base. And they're coming from this world where they always have to pay, they always have to get paid to do this work over and over again for all these different OEMs. And it's just a complete kind of, brain just explodes. The other question I get asked is, how is this free? And I'll sort of come to that in a minute. So one of the things that surprised me is people started using updates on the LVFS as a way of choosing which hardware to buy. This maybe isn't such a surprise for people like kind of Linux users and sort of people using this stuff in the community, but actually the graphs like you can see now were a direct kind of ask from the UK government, because they said, look, we want to choose laptops which are supported on the LVFS, and we don't want to choose laptops that only have, say, one update just so they get the little green checkbox. But we actually want to see that they're actually supporting these laptops over the last few years. And so there's now public graphs on the LVFS, which means you can just look at every single model and see how long has this model been supported for. And here you can see there's a XPS 15, which I guess on average probably has about 1 update per quarter, which is fairly typical. And some vendors are very good at this. Other vendors might only release 1 or 2 updates the first year, and then they become kind of like just critical security issues only. This is quite a surprise. This is something that I didn't expect. But it also means it's been, so like, is on the LVFS is now been baked into various US and UK purchasing policy, which is kind of, for an ecosystem, that's brilliant. Now, like I said, a lot of people are very surprised this is free. They don't understand that the question I get asked all the time is, how long is it free for? Like, at what point do the fees kick in? And the way it works is, like my job is being paid for by Red Hat, and Red Hat are paying me to kind of build this ecosystem and build all these different companies and this shared code. And I think what happened, I guess a couple of years ago, is the likes of Dell, Lenovo, HP, etc., went to the Linux Foundation and said, "Look, we're building this multi-million-dollar business on this Linux kind of pipeline, and we're relying on this random bloke in England with this server that's running under the stairs. Can you kind of sort of professionalize that a bit?" So Linux Foundation now, they supplied a couple of sysadmins, which basically took my web service, made it Amazoned, made it into microservice. It's all running completely scalably now. It's all backed up minute by minute and stuff. And it's great that it's also not my problem. So if it goes down in the middle of the night, someone else gets paged and they fix it. And that's great. Also, the key thing here is that Red Hat is this neutral party. It's like the UN. So it's like when if Dell had gone to Lenovo and said, "Hey, do you want to join this Dell.lvfs.com thing?" Probably Lenovo probably would have said no. But seeing as Red Hat is this neutral third party that doesn't really have any skin in the game either way, it's sort of really useful like that. Of course, I don't scale. I'm just one person, and I can't deal with 30 different OEMs. And so there's I think it's about a dozen different consulting companies now, which provide like people provide the ability to write plugins or converting old legacy code to the new kind of G-Objecty code, or just train people on how licensing works and how the LVFS actual like UX works as well. So let's get into the more interesting part to the presentation. Oh, there's one more. So there's one of the things we trialed is any engineer can have an LVFS account. They don't have to go through the whole legal thing if they just want to test things out privately, which meant that we could sort of build the ecosystem using the engineers. So a Realtek engineer could go create an account on the LVFS, upload Realtek firmware, find out how easy it is, and say to his boss and say, look, well, this is something that's going to cost us no money and get us a huge amount of PR and means we can bid on these contracts. And then it's not me talking to sort of like the Realtek CTO, it's some manager of some manager talking to the Realtek CTO, which is a good way of sort of onboarding random companies to try and do your thing. But really, at the end of the day, the OEMs just want an easy life. Like Lenovo told all their ODMs, their suppliers, that LVFS and fwupd is required. Dell, similar. Google have basically said that if you don't do the fwupd thing, you lose the Design for ChromeBook. Also, Works With ChromeBook sticker, which is a big deal apparently. But they don't require use of the LVFS, which is fine. And the idea is here that the OEM can choose any rules it likes. So you can make it someone else's problem rather than having to worry about all the different relationships. So I guess this is the slide that's more important from an LAS kind of building an ecosystem point of view. So I guess the main things here is that we want to be installed by default. If someone like Lenovo went to Red Hat and said, hey, we've got this new architecture, this new script, or this new binary we use to install firmware on these servers, rather than saying, well, you could install this other thing, which also does the same thing. If you're installed by default, it means we already have something installed. You probably should use the thing that's already installed, rather than having to install this extra thing. Also, because it's being like it's already part of RHEL, it's not a case of it's adding one extra file to a package rather than adding a whole new package and sort of defining an SLA and maintainer and all that kind of stuff. So actually, the benefit of it being there is amazingly important. The other thing is being enabled by default. So, like for instance, Ubuntu, I guess it must be great having the Snap Store enabled by default, and it's not a luxury we have in Fedora with Flatpak. Maybe in the future, but not now. So having the LVFS enabled by default means that rather than someone like HPE saying, could you add this extra remote so that all your servers contact this web server so that we can get firmware updates, because there's something else already installed by default, you can say to them, just use the thing that we already have, which is quite a compelling reason rather than just saying you can do one or the other. Also, the idea of the plugins were that you could have the IHV for VIA, who make like USB hubs and lots of other stuff, can own that bit of the code base. They don't feel like they're completely out of control, that they have no control over this open source project. They are kind of integral part of it. And it kind of means they have their own little like fiefdom, which they can sort of control. The second point, I guess, is kind of against the idea of trying to avoid architecture astronauting, but sooner or later you do have to just build functionality and kind of hope someone's going to use it. And so I'll be developing features, like especially with the plugin library, where I wasn't quite sure which vendors were going to be joining, but I kind of knew that we'd probably need some, I don't know, USB control transfer abstraction, or we might need some, I don't know, Endian safe byte read functions. And so sooner or later it does come down to actually writing some code so that the first person who says, hey, I want to be part of your club, doesn't have to write half the ecosystem before they can actually do something worthwhile. This means that for the first year or two, it was me writing an awful lot of code late at night, kind of praying that someone would use the code that I'd spent all this time writing. The other, I guess the last point with that is, right from the start, it was made very obvious by every single OEM and ODM I talked to that forward and backwards compatibility were a must. You can't just convince millions of people running Linux, all sorts of old Debians, and the people running with some Arch Linux system. You can't convince everyone to update to something at the same time. And in the same way, you can't ask OEMs who have literally put things into contracts with their suppliers to do something a different way now. And so all the file formats and all the metadata are all forwards and backwards compatible. So you can take a package that's been uploaded today and install it on the oldest Debian stable And similarly, any package that was uploaded at the moment stable, you can deploy it with the latest fwupd. And that compatibility forwards and backwards is really hard. But if you design right from the start, it's the difference between another kind of ecosystem where you don't have that compatibility. Last point on this slide is we designed the system to not be cloned, in that we didn't want there to be an Intel LVFS. Now, you probably trust Intel because you're running an Intel processor, you have Intel microcode running right now. Because we didn't want things like an HPE LVFS. It'd be weird if you're on a Dell laptop for it to be pinging support.hpe.com every day. If nothing else, from a privacy point of view and a bandwidth and a power usage point of view as well. But also some vendors that you're using stuff like, if you're using a Bluetooth mouse, you're probably using Pixar, which is probably a company you've never even heard of, and you'd get kind of freaked out if your PC was contacting them every day with your IP address and user agent. So the idea is, although it's all open source code, and even the website is all completely GPL code, you actually to spin up an instance is actually quite hard. And because the signing key is part of the fwupd package rather than downloaded from the LVFS, there's deliberately no way of adding extra signing keys or updating existing signing keys or adding remotes for other vendors. And so it's a case of you either play by the rules that we've got or you can't deploy your firmware, which is kind of an aggressive but kind of essential part of not being fragmented. Like this is like, it's like a hugely monolithic kind of design, but it wouldn't have had the success that it had without these kind of sort of strict rules that stopped this fragmentation for, I guess, a few different reasons. The other thing that's important is the OEM already does things a certain way. Like Dell already calls their firmware package tag, and Lenovo calls it a build package name. And so by providing it a way of, basically, this is like an hour's work, but it meant that the Lenovo engineers that were uploading firmware could see the terms and the URLs they were familiar with, rather than forcing them to learn about things like build package names or something. In the same way, like with Flatpak, you wouldn't maybe expect the Microsoft engineers to learn about the Flatpak manifest, because it's the technology they're not using already. So maybe there's some sort of like work that can be done there, making it kind of more similar to the system that they're using already. And also existing contracts exist between companies. This is maybe less relevant from an app ecosystem point of view, maybe more relevant from a firmware ecosystem point of view, but you can't assume that your new fancy distribution method is going to be the one that's going to be the only one that people are using. So you kind of have to assume that, for instance, here that Wistron or Foxconn or whoever the ODM is supplying hardware for an OEM, whom that firmware might have come originally from the IBV, like Phoenix or AMI or something. And so the LVFS has this idea that all the different companies would log in and then the firmware can be shared between companies. So we kind of we did all that work to integrate all these different suppliers, which when the easier thing to do would be just let Lenovo upload the firmware. But it means that you're not then embedded into their supply chain. You're just sort of just like a FTP site. Now, this meant that now when the contracts are negotiated between the ODMs and the IBVs, that the LVFS and having an engineer that is familiar with uploading to the LVFS is part of the contract, which is awesome, because this means that the ecosystem gets kind of cemented into this kind of this firmware thing, and it's working really well. But of course, you're not the only ecosystem. So in the same way that Flatpak has Snap and Snap has Flatpak, there are two worlds, or there are multiple worlds. And so our worlds at the moment are Windows Update and the LVFS. And here a company called Eclipsium have access to some of the Microsoft data and also from the vendors themselves. And we've actually provided tools for the vendors to kind of remind them when maybe Linux users might have got left out. And there's, I think in Will's talk yesterday, there was some about some of the work on Flatpak manifests, where it might not be the Flatpak is being uploaded by the original software author, and it might be that the original software author has chosen a different world to upload their software to. It's actually giving the kind of the packager the tools so that they know when things are out of date or when things need updating, or even automating it completely. Like, for instance, Dell this is very useless for Dell because Dell has this build pipeline which automatically has a robot user which uploads firmware for various different models, which then gets QA'd by real people and then pushed to stable. But for someone like Lenovo, where it's a bit more manual, this is really useful, and they can see at a glance what software is maybe not up to date, both on LVFS and Windows Update. So we've supplied like 27.7, it's like 28.0 now. Firmware files, it's like a 1.2 million a month or something now. But that might be a massive underestimate, because as I mentioned right at the start, we have the idea of where you can mirror the entire LVFS without us knowing about it for either security, privacy, or any other reason. But we know that 2.1 million people have reported back success, which is not unexpected because we only ask 1% people using the console. So you can kind of like use some back of the envelope maths and probably say that we've supplied really over 100 million firmware files, which is something I'm really proud of. And when you take those numbers to an OEM and say, look, this is the number we know, and we know that 12 million people every day look for the latest update, that's kind of super numbers that kind of take people's notice. So Dell said that it's now strategically important for them to support the LVFS. They've had a lot of good PR and also good business from this. Lenovo has said that standardizing has been seamless, and I was just talking to Intelligent a few days ago, and they said they use Windows Update and LVFS, and they called the Windows Update system painful, and they said it could compare it being night and day compared to using the LVFS, which I took as a really big compliment. And there's various people asking, can we use the LVFS on other platforms? So Google already using it on Chrome OS. People saying, well, can we use it on Windows as well? Which is something that's kind of blurs a line a little bit, and it's not something I'm super comfortable with. But yeah, maybe, I'm not sure. So thank you for listening. I rattled through this really quickly. I have a personal email, Red Hat email, and I also have Twitter. If you can talk to me, grab me on any, and talk to me about any stuff. Thank you for listening, I guess.
Shared notes on the left side of the screen.
Right, shared notes. Right, so we have some questions.
Yeah.
So, how hard is it to get into the firmware world without very little experience? When you graduate, how hard it is to find a company that hires you and provides lectures to put your knowledge about programming and all the ecosystem of firmware, hardware, etc. So I guess it's a kind of a big question, but I'm an electronic engineer by trade. So I graduated from Surrey Uni, went to work for a defence contractor doing electronic stuff, and kind of got into software. But really, like, firmware isn't this big scary thing. Like, programming on an Arduino is firmware. Like, when you flash an Arduino, that's what I call firmware. So all you have to do is like play with something like a PIC microcontroller, microbit or something. And we have people distributing firmware on the LVFS for Arduino stuff. So you don't have to be some massive company like Dell. Some people might only have 200 sales of some product from some open hardware product, and they use the LVFS for distributing that. That's sort of super useful for them. Right, I guess that's sort of fudged that first question. Second one, how do you persuade companies to add their hardware firmware to LVFS, and is some company easier to persuade than others as the GNU Linux doesn't work it? So it's really hard. So ask me that question 5 years ago, and I would have said you have to ask on Twitter, find their social media account, try and get a contact in a company, file bugs, call the support line, etc. Nowadays, that's less true. Nowadays, it's vendors who are bidding for government contracts finding they can't bid unless they have support on the LVFS for their firmware, because the government contract wants to use the LVFS service to avoid obsolescence or security issues, or for some sort of certification. So it's kind of changed in the last 5 years from me pleading with vendors to them pleading with me. So I've had vendors come to me in the past and said, look, we have this multi-million-dollar sale, and we can't complete this sale with this customer until the LVFS stuff has happened. Can you just say that the LVFS stuff has happened, and then we'll do it in the next few months? And I'm like, so that's fraud. And anyway, so heaven and earth gets moved, and they actually do the work that they need to do, and the contract gets signed. So I can kind of switch from being kind of asking like nicely to kind of being blunt, being an asshole, because I can say, I need you to use this metadata format, I need you to supply this data, I need you to do these steps, I need you to do this legal release, I need you not to have a EULA, I need you to not have a warranty statement, all this kind of stuff where I can be quite blunt now. And actually, although the Linux market is 2 or 3%, that's kind of the consumer kind of side of the Linux market. If you're someone like the US government, UK government or something, you're not the sort of person that's going to be filling in a survey that says, oh, I use Linux, I use this distro, I use this hardware. So my gut instinct says that like in enterprise, it's just hugely bigger than that number. Just looking at the amount of effort companies put in on this kind of stuff. The other thing, of course, is Chrome OS. When Google turned around and said, we want to use fwupd on Chrome OS, which was, I guess, for three reasons. One was they had a huge number of updaters on their in their MMC storage that is really expensive, and each updater was set like a 60 megabyte statically linked blob, and with fwupd, each one of those updaters is a 15 kilobyte blob because it's all using this shared functionality. The other thing is security. So the security team at Google could actually review the code and say, look, this has passed our internal security review, and we're going to build it and then distribute it to thousands of computers. And it also meant that they could distribute firmware updates, all the stuff that we developed on Linux, and use it on Chrome OS with almost no work. They could just integrate it into their own boot process, which meant that the whole kind of Works with ChromeBook certification, which to me is just a sticker, is a huge deal for all these companies. So Christmas last year, I had about maybe 30 or 40 different companies sort of contact me and say, look, we need this, otherwise we lose the sticker. And so it was a very busy couple of months telling people about licensing and how we collaborate and how pull requests work and that kind of thing. And that's where the need for the consulting companies came. So like the 3M Debs, the Collabras, all the other kind of the companies that we're familiar with from like developing Linux apps are now the ones that are helping helping the vendors get their firmware on the LVFS and also get their flashing protocols into fwupd where we can all share them. So last question, would you envision LVFS being used on more bespoke systems like cars and other IoT devices? Really good question, and I know people are using fwupd on, there's a, I guess, big oil company which is using like a bazillion IoT nodes for measuring ground movement, and they're using fwupd to deploy the firmware. Now, they're not using the LVFS because what they want to do is they want to do like a staged deployment. You don't want one update which bricks 10,000 nodes. So they're doing test deployments on like lab versions of each different type of hardware, and then before it goes out onto these sort of thousands of nodes, they're actually, I think they're using like something like Ansible or something like a Puppety type thing to deploy the firmware using fwupd. So the fact that the firmware has been obtained from the LVFS is really useful for them because it's signed and they know where it's come from and they can rely on the vendor to supply updates for this hardware. It's probably more useful for them to control distribution themselves, which is something we kind of I don't get into the whole kind of like fleet management stuff. That's not something that I think fwupd or the LVFS wants to deal with. Basically, here's the metadata, here's the mechanism, and you can connect them however you like, just kind of also how people like Google do it as well. So I think that's all the questions, and I think I've got no time. So thank you all for listening. If anyone wants to contact me, use Twitter, use my work email, use my personal email. I'll be happy to answer questions there as well.